All right, you guys, in this section, we're going to be talking about graphing quadratic equations. Okay, the simplest form of a quadratic function that we have makes this shape, which is called a parabola. Okay, even if you didn't know the basic shape, you could always find it by plotting points. Plotting points means that you choose some x values, okay, and from those x values, you plug them into your function to get your y coordinates. So these are the x values that they chose. And to get the matching y coordinates, they plugged each one of those x values into the function f of x equals x squared and found the corresponding y coordinate. And then they plotted those, which gave us this picture on the right, which is called a parabola. Okay. So on this function, the domain, if they ever ask you, the domain is talking about the x values or the input values. Okay. The domain for this function is from negative infinity to positive infinity, which means you can plug in any x value that you want into this function and get a value out. Now the range is talking about your y values. That means that the y values that come out of this function are positive. So the range is from 0 to positive infinity. All right, so like we said previously, the name of the shape on the right is called a parabola. And to graph it, we typically put our quadratic in standard form, which is f of x equals ax squared plus bx plus c. And that shape that's formed is called a parabola. Now, based on how the original equation is set up, you can tell how this parabola is going to look by looking at the leading coefficient. So the leading coefficient is a, and depending on what a is, it will tell you whether or not your parabola will open up or if it will open down. So if a is positive or a is greater than 0, then that means your parabola is going to face up, like the one that's in our picture on the right. If your leading coefficient is negative, which means that a is less than 0, that means that your parabola is going to face down. Okay? So depending on what your leading coefficient is, it will tell you whether or not your parabola faces up or down. Okay? Now on our parabolas, we also have two other pieces of information that we can find. So parabolas are symmetric with respect to a line, and that line is called the axis of symmetry. Okay, so typically we tend to look at parabolas that face either up or down. So your axis of symmetry is always going to be a vertical line for these parabolas. Okay, when we go in to draw our axis of symmetry, we typically use a dashed line. Okay, and what that means is that our parabola is symmetric, which means if we were to fold our parabola along that line, both pieces of the parabola would match up. Okay. Now, the other piece of information they will ask you to find is the vertex. So regardless if your parabola faces up or down, it will always have a vertex. If your parabola opens up, then the vertex is always going to be the lowest point. Okay? And another way to find the vertex means that it's the point at which the graph changes directions. So if we're looking at our parabola that faces up, on the left side of the vertex, the function is decreasing. We know it's decreasing because if you think about your graph like a roller coaster, as you're moving from left to right, the graph is going down. So your graph is decreasing on the left side of the vertex. It changes directions at the vertex and then it increases. So you can see at the vertex, the graph changed directions. Now the opposite occurs on the parabola on the right. It's facing down. So because it's facing down, it still has a vertex and an axis of symmetry. It's just on the left-hand side of this parabola, it's increasing. So if you think about it like a roller coaster again, as you read that graph from left to right, the graph is increasing. You then hit the vertex, and then the graph is decreasing on the other side. Okay. So if your parabola faces up, your vertex is going to be your lowest point. And if your parabola faces down, your vertex is going to be your highest point. But either one, both has a vertex. Cool. All right. Now, not only will we be identifying where the axis of symmetry in the vertex is, we're also going to be shifting our parabolas. Okay. Now, there's two ways that your parabola can shift. Your parabola can either shift vertically or it can shift horizontally. So a vertical shift that means that your parabola is moving either up or down. Okay. All right, so it's moving up or down. Vertical shifts happen on the outside of your parent function. What that means is that your vertical shift is going to appear as f of x plus k or f of x minus k. So on our parabolas, for example, we're used to our function looking like f of x equals x squared. If that graph were to have a vertical shift, it would look like this, plus 2. Do you see how the 2 is on the outside of the parent function? That lets us know that this graph is going to have a vertical shift. When we are moving vertically, we follow the direction of the sign. So in this example, because I've added 2 to the function, we're going to move up 2. Okay? If I were to have x squared minus 2, this is still a vertical shift because that 2 is on the outside of the parent, but my graph would be moving down because my sign is negative. Okay? Now the other way that your graph can move, it can move horizontally. If your graph is moving horizontally, it means that it's moving either left or right. Okay? Horizontal shifts happen on the inside of your parent function, so they will appear as f of x plus k or f of x minus k. So, for example, if you were to have f of x equals x minus 2 squared, do you see how this negative 2 this time is on the inside of the parentheses? This lets me know that I'm going to have a horizontal shift. And for a horizontal shift, I always move in the opposite direction of the sign. So usually for a negative number, if we were on the number line, we would want to move to the left. But this tells me I'm going to move to the right because the number is negative. I go in the opposite direction. If I were to have x plus 2 squared, this would tell me to move to the left because the number on the inside is positive. Okay? Now, the way that I remember this is a little unorthodox, but bear with me. So the way that I remember horizontal shifts is I look at the first 2 letters of horizontal, and they happen to spell ho. All right? So the way that I remember that is hoes never do what you tell them to do. So a horizontal shift is going to go in the opposite direction of the sign. Now, don't tell anybody I told you this. I'll deny it. So vertical shifts always move in the direction of the sign, either up or down, and horizontal shifts move in the opposite direction of the sign, either left or right. All right. Another thing that we could change is the shape of our graph. So the coefficient of A, which is our leading coefficient, determines whether the graph is narrow or wide. So if our leading coefficient, if the absolute value of it is greater than 1, our graph is going to be narrower than normal. Okay? If the absolute value of our leading coefficient of A is less than 1, then our graph is going to be wider than normal. So if your absolute value is greater than 1, your graph is going to be narrower. And if the absolute value of A is less than 1, your graph is going to be wider.